Bismillahirrahmanirrahim. This is another video on Laplace transform from another book, and in this we'll be primarily solving practice problem number 14.4. Now let's go through the definition. The two-sided Laplace transform defined for a function ft as integral minus infinity to plus infinity e minus st ft dt, and the one-sided Laplace transform is defined from 0 to infinity or 0 minus to infinity. So you can see the difference. This one is starting from all the way from negative infinity going to the positive infinity, whereas this one is starting from 0 to infinity, and the rest of the terms remain same. Now, just for your information, this definition is also written as shown here, ft e raised to the power minus st. So whatever is the function, we multiply that by e raised to the power minus st, and then we take integral of that function. Okay, so this is practice problem 14.4. Here ft is given as shown here, and we have to find the fs for two-sided and one-sided. So the Laplace transform, two-sided Laplace transform and one-sided Laplace transform. Now I'll not go into the explanation of this. I'm sure you are familiar by now, but we don't need really much details of this, so we'll just proceed. The two-sided, proceed with the definition, so minus infinity to plus infinity e raised to the power minus est and the function. So this is the function that we have, so we plug in that function. So the equation will now become est and the function here as given in the question and dt. Now the two e terms we combine, so it will be e raised to the power minus 2 plus st, and this is the unit function. And now we separate the two terms, the two unit functions. So this multiplied by the first term will come here, minus this multiplied by the second term. So we got now two terms. Okay, so we were here, and now we'll take into consideration the meaning of ut plus 3 and ut minus 2. So I'm sure you can recall that ut plus 3 means when we put t plus 3 equals to 0, the starting point is minus 3. T plus 3, 0 means t is equal to minus 3, so it is starting from minus 3 and going all the way to positive side or the infinite, and its amplitude is 1. So the conclusion that we can draw from here, that in this case the starting point will not be minus infinity, rather it would be minus 3. And same if you look at this, ut minus 2, t minus 2 equals 0 means t equals 2. So this one is starting from t is equal to 2 and going all the way to plus infinity. So that means now here the starting point will be plus 2. So this is the only catch in this question. So let's put the limits, minus 3 and here minus 2, and now ut plus 3 will be replaced by its value 1, so it is 1, so we replace that by 1. And now we'll take help of this integral formula. Integral eax dx is 1 over a e raised to the power ax, so we'll apply that formula. So minus 6 out, e raised to the power minus 2st at the top, and divided by this factor 2s or minus 2s. So minus 2 plus s, we divide that. And similarly here, same thing. Minus and minus becomes plus 6 e raised to the power this, and integral when we do, it will be divided by minus 2s. So just this formula keep in mind. And then we put the limits. Now plugging in or just taking this term out, minus 6 divided by minus 2s, and here 6 divided by minus 2s. And now we can easily plug in the values of t is equal to infinity and minus 3. So this term will be e raised to the power minus 2s infinity minus e raised to the power minus 2 plus s, and this value 3. And similarly here, and now I'm sure you can recall that e raised to the power minus infinity is actually 1 over e raised to the power infinity, and e raised to the power infinity will make it infinity, and 1 divided by infinity is 0. So e raised to the power minus infinity is equal to 0. So we can replace this by 0, and similarly we replace this term by 0. So what is left here is this term and this one here. We multiplied with the 3 this one, and we multiplied by 2. And now we take this term 6 divided by 2s common. So here 6 divided by 2s with the minus sign. So we take this. So the first term minus, but because of plus, and but because of these two minus will also make that plus. So it will remain plus e raised to the power minus 4 minus 2s. And this we can just write the positive term ahead and the negative term at the end. And so this is the answer given in the book, which is same as what we have. And now we'll be doing the one-sided Laplace transform. Exactly same way we'll proceed, only that now we have replaced this minus infinity with 0 minus. And I hope this concept of 0 minus is clear to you. We are starting slightly ahead of 0. So whatever is the change at 0, that is accounted for. Anyway, we are following exactly same pattern. Put in the value of ft, then taking this term out, or multiplying these two and taking out, separating the two terms, plugging in the limits. Now, here is a catch. This one, although it is starting from minus 3, but since we are considering unit one-sided fs, so this will start from 0 and not minus 3. So that is, you have to keep in mind in case of one-sided. The second one does not matter because it is already starting after 0. So this one will become 2. And following the same pattern that we did in the previous case, putting in the values here, this term becomes 0, this becomes 0, this will become 1, so this is 1 and this is 0, so this is remaining here. Taking common, get minus 1 e raised to the power minus 2s multiplied by 2. Further simplifying, we can write it as e minus 4 minus 2s first and then minus 1. So this is the answer, and the answer given in the book is same as what we found. So I hope this gives you an understanding as to how to solve simple bilateral and unilateral Laplace transform problems. Thank you.